Concrete mix design is the process of finding right proportions of cement, sand, and aggregates for concrete to achieve target strength in structures. So, concrete mix design can be stated as concrete mix equals to cement to sand to aggregates. The concrete mix design involves various steps, calculations, and laboratory testing to find right mix proportions. The first part of our activity is the preparation of cement paste. The paste samples were prepared by mixing the cement with water at its respective water-cement ratios, 0.45, 0.5, and 0.55. The amount of cement used was 4 kilograms per sample, with 1.8 kilograms, 2 kilograms, and 2.2 kilograms of water respectively. In the second part, the cement mix was prepared using 4 to 8 to 12 proportion. 4 parts of cement, 8 parts of fine aggregates, and 12 parts of coarse aggregates. The cement ratios of 0.45, 0.5, and 0.55 were also applied in the concrete mix. After mixing, we conducted the slump test for each sample. The mixture was then placed into cylindrical molds. The mortar and paste were stored for 24 hours in a suitable location, and after the said duration, the specimens were then detached from the molds and curing for the mortars and cement paste took place. On the 7th day of curing, the cement paste and mortars were taken out of the curing tank and were air dried for a day before it will be cast for testing. The weight and dimensions of the test specimen were shown below. The testing for the test specimens is shown in this video. The compressive strengths of mortars were determined at 7 days of age after wet curing. Here, the compressive strength of mortars and cement paste is determined by applying continuous load over the specimen until failure occurs. The test is conducted on a universal testing machine. Using the universal testing machine, we were able to come up with the following test results, showing the mortars and cement paste with their respective maximum load sustained in kilonewtons. As shown in the table, it is the result of the maximum load sustained in kilonewtons. Also, the compressive strengths of the cement paste and mortars were calculated using the equation CS equals to Q over pi r squared, where Q, load at failure, kilonewtons, R, radius of the specimen in mm. Below shows the calculated compressive strengths for the test specimens. With this result obtained, we can conclude that the higher the water-cement ratio, the higher will be the water content per volume of concrete, and concrete will be more workable. Higher water-cement ratio is generally used for manual concrete mixing to make the mixing process easier. For designated mixed concrete, the strength and durability of concrete is of utmost importance, and hence water cement ratio is mentioned with the design. Generally, designed concrete uses low water cement ratio so that the desired strength and durability of concrete can be achieved. In this activity, several recommendations can be made to improve future experiments. 1. Enhanced test planning. Careful consideration should be given to test limitations, potential influencing factors, and appropriate sample sizes to ensure more accurate and reliable results. Number 2. Quality control. Strict quality control measures should be implemented to ensure the consistency and reliability of raw materials used in the concrete mixture. Number 3. Standardized procedures. The use of standardized procedures and protocols for concrete preparations, curing, and testing can help minimize variations and enhance the repeatability of results. 4. Monitoring and documentation. Continuous monitoring and thorough documentation of all experimental parameters, including environmental conditions and testing procedures, can provide valuable insights into potential sources of error and aid in troubleshooting. Number 5. Collaboration and expertise. Seeking guidance from experienced professionals or collaborating with experts in the field can help address any challenges or uncertainties and ensure the adoption of best practices. By implementing these recommendations, future lab activities can strive toward improved accuracy, reliability, and consistency in obtaining meaningful results, ultimately advancing the understanding and application of concrete technology.